Hello, and welcome to the video series for Math 181 at UNLV. This is the Calculus 1 class. Before we get into the notes for this class, the various chapters, just want to talk to you guys a little bit about calculus versus some of the math you've already had. So the math you've already had, it deals with what we would think of as like static math. Inputs and outputs, get your one answer. With calculus, it's more fluid. It's talking about motion. It's talking about values as the motion changes. So for instance, if you drop a tennis ball off the Stratosphere Hotel, its speed at any point in time is changing, and how could we calculate values like that? That doesn't mean that the math that you've had is not relevant. So for instance, for Math 126, the algebra that you learned there, the factoring especially. So if you're not very good at factoring, I can tell you now, brush up on it. There's going to be a lot of factoring throughout the semester in this class. Radicals. So how do we deal with radicals? How can we change them to fractional exponents? If we move it to the denominator, how does that change the exponent? Things like that. And as well, domains. So domains and ranges. We're going to talk a little bit about domains in the videos, this first set of videos here. But domains are super important in terms of calculus. For Math 127, if you took that one, that's the Pre-Calc 2, or it's basically like the trigonometry class. There, your unit circle measurements, you have to have those down, or if you've taken my class before, you have that blue sheet with the measurements on it. Make sure that you have that accessible at all times, because when we're doing some calculus with the trig values, you're going to have to be able to figure out what those values are. Sine of 0, cosine of 0, sine of pi, things like that. So have that readily accessible so you're not always having to go back and research it if you don't know it by heart at this point. The basic trig graphs. So what does a sine graph look like? What does a cosine graph look like? What does a trig graph look like? And their inverses. What part of those graphs are we talking about? And again, what's the domain and what's the range for the inverse functions? And then lastly, and I know this is something I've always stressed to you guys before, but just your basic math, not making those dumb mistakes. There is a lot of algebra, especially as we get further into the semester here, distribution, canceling out, factoring out, things like that. And if you make, the problems will end up super long, a lot of algebra that you're doing, and if you make one tiny mistake at the very start of it, the entire remainder of it's going to be incorrect. So maybe slow down just a little bit, get in the habit of really checking yourself as you progress through a problem. It's going to save you a lot of headaches and frustration later. Okay, so this is Math 181. This is chapter 1, section 1, and just as with my videos for Math 127, I'll give it to you guys like video part 1 of whatever, and there'll be 2 videos for this section. This is video 1 of 2 videos. So again, first off, this is chapter 1, and we're going to be talking about functions and limits. And for this specific section, so section 1.1, we have functions and their representations. So hopefully you somewhat remember your functions from Math 126, a little bit from 127. Let's get some definitions about it though. First off, for a function, this is when one quantity depends on another. Depends being the key word here. What's the most basic function that all of us know about? It's your paycheck, right? So if you're getting paid $10 an hour If you work 3 hours, so that's the one quantity, you get paid how much? Well, 3 times 10, so the other quantity, the quantity that we're worried about, how much money are we getting paid, depends on how many hours we're working. If we work 8 hours, if we're getting paid $10 an hour, that's $80. So that's the idea of a function. You put in one number, it kicks out another value. The domain. These are our possible input values. So if we're talking about a paycheck, it's what? 1 hour, 2 hours, 2.5 hours if you're paid, by the actual time, and if you're getting paid on a half hour or something. Those are the values that we can put into the function. The range. These are the output values. So again, if we're going back to this idea of a paycheck, if I work 3 hours, the domain, the input value, the output value would be $30. So any of those possible values, that is our range. We have this notion of independent versus dependent variables. So independent, these are the ones that we can choose, that we have control over. So again, if we're talking about the paycheck, I can work 4 hours, I can work 2, I can work 8, I can work 10. Those are independent. I'm able to choose what those values are. The dependent, we don't necessarily choose these. And so I say don't necessarily because if I work 3 hours, I get paid what? $30. That's the dependent one. So thus the idea here of one quantity depends on the other. Well, if I know that I need to earn $30 to pay for gas, then I can choose to work 3 hours. And then it generates for me this dependent value, this $30 on the other end. What about representations? So what are different ways that we can represent a function? So the first is verbally. So I tell you, you make $10 an hour. That's a function verbalized. Let's do that. So I make $10 an hour. There's numerically. And this is like a table. So if I was to make a table, if I work 1 hour, I get paid $10. 2 hours, 20. 3 hours, 30, etc. So now I have it numerically. If I want to know, well, how much am I going to make if I work 3 hours? I can just look at the table, the numerical values, and know that I'm making $30. There's visually, which is a graph. So again, if I'm talking about the paycheck, if I work no hours, obviously I don't make any money. If I work 1 hour, I make 10, 2 hours, 20, etc. So maybe I have a line graph, assuming that if I get paid for every minute, that it would be a point along this line. So visually, as a graph. And then 4 is algebraically. And this is a formula. And so in this case, maybe my income, I, is 10H, 10 times the number of hours I work. So if I work 3 hours, H is 3, 10 times 3 is 30. So I can have it as a formula. So now that we kind of have an understanding of what it is we're talking about with functions, we get to the domain. And as I kind of prefaced, this is critical in calculus, the domain. What are our possible input values? And we have to be real careful that when we're working with calculus that we're restricting ourselves to this domain, to these input values. So we have the following. When determining domain, it is sometimes easier to find which functions, to find which values the function cannot take. So instead of trying to list everything out, it's sometimes easier just to say, well, the function can't use x equals 5. Sometimes a little bit easier to go that route with it. Our biggest concerns, if you recall from Math 126, if we are talking about domain, is what? Well, there's two of them. The first is even radicals. So for example, if I have a function y is equal to the square root of x, I can't pick every value of x, right? Because I can't have a negative value under the square root sign. So my domain would be what? X is greater than or equal to 0. X has to be a positive number. So that's our one concern. The other concern is what? Denominators cannot be equal to 0. So if I have y is equal to 1 over x, and I want to know what's the domain, what are the values I can pick for x? Well, I can basically pick any value for x, right? Positive or negative, except what? 0. So x cannot be 0. And if I want to write this in interval form, we'll see in a couple examples here how would we do that if we want to write it in a manner that tells us that we can choose any value except that x is not equal 0. So let's look at a few examples. So the first one, we want to find the domains on these problems. First one is that f of x, so remember this is our notation for a function. The function f, when we input x, is x squared minus x plus 2. So I want to know what values can I choose for x within this function. Well, let's go back here and look. Do I have a radical? No. Do I have a denominator? No. So those two I don't have to worry about. So in this case, I can what? I can choose any value of x that I want. So that means what? Any real number. And if we're putting this in interval notation, it would be what? Negative infinity to positive infinity. I can pick any value that I want here. How about the following? G of x. So now I'm just calling the function g. Function doesn't have to be labeled f. Just because it's function doesn't mean it has to have the value f. So this function g is square root of x plus 2. So now if I want to find the domain, now I have one of these concerns, right? Number one, the radical, and it's an even radical. Why do I say even radical? Well, if this was what? The cube root, then I don't really care if it's negative because I can find values for that, right? But in this case, because it's square root, what's my concern? This piece under the radical has to be positive, or it could be 0. So my concern here is that this x plus 2 has to be greater than or equal to 0. So if I subtract 2 from both sides, that tells me x has to be greater than or equal to -2. I can pick any other value, -2, -1, 0, 10, 100, 1,000,000, that's fine. But this is what I'm restricted to. These are the possible values of x that I can have, i.e. my domain. So how do I write this in interval form? Well, I have -2, and I can go all the way up to infinity. Infinity always gets the parentheses, right? We saw this in the first example, should have pointed that out. Whenever we have positive, negative, infinity for writing in an interval, that gets the parenthesis. But -2, so do we put a parenthesis here, or do we put a bracket? Well, parenthesis means what? That the value is not included. It's our starting point, but we don't include it. Bracket means that we can include it. Well, because this is greater than or equal to -2, -2 is a possible value. I can include it, so that would get a bracket in that case. Let's look at one more example. What if I have h of x is equal to 1 over x squared minus x? Radical? No, we're okay there. Denominator? Yes, we have a denominator. That's our concern here, is that denominator piece cannot be 0. It can be any other value, positive, negative, I don't care, but it can't be 0. So what I'm going to say here is x squared minus x cannot be 0. And then I need to determine, okay, what values of x then would cause this to be 0, and I can set up my intervals accordingly. So what do we have to do here? How do we solve for x? Well, we're going to do what? We're going to factor and then use zero property rule. So if I factor out an x, this gives me what? X minus 1. This whole thing cannot be 0. So using the idea of zero property rule, we said each of these x cannot be 0. X minus 1 cannot be 0. Then solve them independently. So x can't be 0, that's done. X minus 1 can't be 0, so if I add 1 to both sides, that says x cannot be positive 1. So I can choose any other value I want except for 0 or 1. So if I'm writing this in interval form, how would I do it? Well, I'm starting at negative infinity, going up until I hit 0. Parentheses or brackets, well in this case it's what? It's parentheses. I'm not allowed to use 0. And then remember, this is our union notation. So I go from 0 to 1. And again, I have to use the parentheses because I'm not allowed to include those in my solution set. And then from 1 up to positive infinity. So I get these 3 intervals of acceptable. Sorry, just check and make sure this is on the video. Okay, it is. So those are my 3 intervals that satisfy what's the domain of this function. This is the domain of the function. I can choose any of these values and I'll be just fine. Lastly, for video 1, if I'm given a graph and someone says to me, is this a function? So let's say I give you this picture. Is that one a function? I didn't tell you what the function was. I didn't tell you if it is actually a function. I'm just saying, is it a function? Or how about the unit circle? If I have that picture, is that a function? Well, how can we tell if we're given a graph if something is a function or not? Hopefully you're screaming at the screen right now. I know, it's the vertical line test, right? So this tells us that a curve is a graph of a function if and only if. So I'm going to make a little notation here. We're going to be using this a lot this semester, this idea of if and only if. So instead of having to write that out all the time, remember I tell you guys mathematicians were lazy? We abbreviated this, IFF. If and only if is what that stands for. So a curve is a graph of a function if and only if no vertical line intersects the curve more than once. So let's go back to these two pictures I drew. If I took a ruler and moved it along left to right, no matter where I put the ruler, what's happening? Once, it hits once, it hits once, it hits once. No matter where I put it along that curve, it's only hitting that curve at one point. So this squiggly line I drew would be the graph of a function. How about our unit circle? If I draw a vertical line, what happens? Pretty much except at the very left and right side of this circle, I'm going to be contacting 2 points. So because I'm contacting 2 points, that means what? That means a unit circle is not the graph of a function. Fails vertical line test, therefore that is not the graph of a function. Alright, that ends video 1 of 2 parts. So come on back and we'll finish up section 1.1.